Okay, good afternoon everyone. Dunggan naman akong mic, no? And maklaro ba ang screen?
Yes, sir.
Okay, thank you. Thank you. So, this afternoon, this will be our topic, two-port systems approach. If I remember last time, we ended with uh, the amplifier parameters of a fixed bias configuration, no? So, we discussed how to compute for the input impedance, output impedance, and voltage gain of a fixed bias BJT amplifier. So di na nato i-discuss ang kung saan pag-derive sa other formulas, especially for voltage divider, unbypassed emitter bias, emitter follower, and so on and so forth. Will only be referring to the summary table on page 293. Okay, for the formulas for the impedances and the gain. Okay, technically parera man gid ang process sa pag-derive sa ilaha. Even if fixed bias sa atong gi-discuss, basically the process is still the same. So, run ako dire for formulas. For formulas, for ZI, ZO, AV, refer to page 293. Okay? Ganun na lang. Okay. Again, para man gid ang process sa pag-derive sa each parameters for the different configurations. And for the formulas for the DC, DC parameters, mato nasa page 193. Okay? Summary table, kaya punta siya. Now, this topic, two-port systems approach, this is a more systematic way of analyzing circuits, more systematic. Now, what do we mean when we say systematic? As you could remember from our first week's discussion, I think I've introduced the systems approach to analyzing engineering systems. So, having that in mind, muna siya ang atong pag-define sa systematic. It's sort of a systems point of view sa any particular circuit. Okay? So, when we say system, we do not need to know what are the particulars of that system, especially the internals of the system. Meaning, pwede lang nato i-analyze ang isa ka complicated system, whether simple or complicated system, we could analyze it using a box, no? Or sometimes they term this one as a black box, meaning natakab lang sa sulod. So if this is an amplifier, so this is our amplifier. So di na necessary nga makabalo tayo if this is a fixed bias na amplifier or voltage divider, okay, or emitter follower or whatever. So mara lang siya black box and maka-communicate ta sa atong system through its inputs and outputs. So muna yung input, muna yung output. So it will be characterized by its system parameters, input impedance, output impedance, and voltage gain. Nga katong gina-discuss. No? So for a one-stage amplifier, such as this one, okay, what are some external factors man na that we could connect to our amplifier? So basically, nanantay duha. It could be nga pwede ta mag-cascade of amplifiers, no? possibly this is just one of the many amplifiers nga i-connect nato siya with. Or if singular lang siyang amplifier, sa left portion sa atong system, di nato i-connect ang source. No? Di nato i-connect ang source. And the thing, or the source drives our amplifier, or our system, so to speak. And the thing that is driving, or that is being driven by the amplifier, is what we call the load. No? So if I could also remember na mention naman ako din ng mga terms, at least kaning mga terms, source and load. Okay. Isa sa mga specific examples of sources could be the signal source. No? It could be a signal source. Or pwede sa sensor. We connect our sensor here. Sa load, it could be another system. No? Meaning, possibly another amplifier gihapon. Ang counterpart sa sensor, sa load na part, ang iyang counterpart, no, sa load na portion is an actuator. Okay, actuator. Or pwede na good plain na resistor, no, as the load. Resistor. So many things na ito pwede ma-connect sa load and even sa source. So we need a model, no? We need a model or a convention to model our sources and loads. Kung another amplifier siya, well, we don't need another one because pwede naman siya butan nato box here. Another box here. Okay, if amplifier ato i-connect sa load o sa source sa atong system in question. But for a specific na source, especially signal sources and sensors, we could model it using a voltage source, especially an AC voltage source, and a resistor. So this resistor is the internal resistor of our source. We call our source as VS, voltage source, and our internal resistor as RS, or source resistor. Sa load, pwede lagid plain nga resistor to model our load, and we call that one RL. So this RL could be a speaker or even an actual resistor, no? A speaker, an antenna, no? If the amplifier will be amplifying electromagnetic signal, kung sound kay speaker, kung some sort of pulse width modulated signal, pwede motors, yung load, or heating element, or whatever. So it could be modeled using a plain resistor. So this is our system's approach to analyzing amplifier circuits. One stage lang yung amplifier, no? Or singular amplifier lang ni siya. Pero di man gapon mag-matter if multiple stage amplifiers. Okay, magbutan lang gapon tag-box here after sa amplifier, then dito lang gapon i-connect ang load. No? So, again, doesn't matter what type of circuit configuration our amplifier is, we only need to know its input impedance, output impedance, and voltage gain. Yan na lang. So far, the voltage gain that we've computed is unloaded. Okay, unloaded. Muna ang specific term sa mga voltage gain nato na compute so far. Well, unloaded because wala pa man tagi-connect na load sa output portion sa itong amplifier. Okay? So the voltage gain is unloaded. Usually, ato untang i-denote na siya og AV and L. Okay? So kato atong gipang compute na load sa 293, those are AVNLs. Okay? No load voltage gain or unloaded voltage gain. So karon pa nato ni gi-introduce na name niya kay wala pa mo naka-introduce gani nga concept before. But now, let's start referring to it as AVNL. Katong mga AV na itong ipang compute before. Now, we'll assign the name AVNL to it. AVNL. So, if na unloaded voltage gain, na loaded voltage gain, yes, na loaded voltage gain. If na load ang atong amplifier. So, if loaded, no? So, for loaded voltage gain, so loaded amplifier, kibalid ay. So, for loaded amplifier, its gain is AVL. Okay? Loaded voltage gain. So, kani, conventions ni siya. Hindi siya big deal pa. Pero para di ta malibog kay actually we'll be computing 3 types of gains. Na ay unloaded, na ay loaded, o na pa isa. For amplifiers with sources, meaning na ang gi-consider na nato na connect na ang source sa input na portion. So for amplifiers with sources, its gain is AVS. Okay? So that's voltage gain. Taas mo kayo, no? Voltage gain with the effect of source. So, wordy man siya, AVS na lang. So, nanatay idea na connected na og source ang ato amplifier. So, these are the 3 types of voltage gains that we computing. Okay? So, na siya na-connect na sensor or signal source sa atong amplifier. Okay? And a sort of a basis lang today conclusion, AV and L will always be greater than AVL. Okay, so kung mag-compute ta, dapat magkuhan lang ni siya, no? Kanang pang-check lang that the no load voltage gain will always be larger than the loaded voltage gain. So having said that, the effect the effect of the load to the system is significantly lower down niya ang value sa iyang gain. So kung butangan na to gain, butangan na to og load ang atong amplifier, maapektuhan iyang gain. Okay? Same gyapon ang effect if connect ta og source. Again, significantly ma-reduce ang gain, ang overall gain sa system if included na ang source and ang load. No? Okay. So how will we compute, no, for each of this one? Technically, there are 2 ways to do this one. So, for example, ato i-consider ang atong fixed bias na amplifier right here, no? And compute na taog voltage gain. So, it's unloaded voltage gain. Once i-connect na to ang load at this part, so this is RL, we compute na to everything, no? Mag-derive na punta again. We'll be deriving the formulas again because tungod kay nag-connect na og resistor here, yeah, di ba, maka-affirm man ta nga nabag-o gid ang circuit. So of course, mabago po ang mga values for input impedance, output impedance, and gain, no? And gain. So, if connected na ang RL sa circuit, so dili na siya unloaded. Loaded na. So, sugod na po ta from scratch, no? To compute for the load. As the gain with the load. And malahi na po na siya kung mag-connect na po ta og source here. Malahi na po ang atong formula. Subak na po ta susugod para ma-compute ang AVS. So, tedious kayo. Pero di naman na siya tedious gyud kay namatay table. Ano? But we'll be referring to three different tables lugar. Kay lahi ang table for unloaded, lahi ang table for loaded, lahi ang table for with the effect of the source. So, haso lang gamay. Pero na another way, no? Option number 2. Sticking with the concept of a two-port system or a more systematic approach, we could compute for the loaded and the source voltage gains even if dili na ta mag-derive, no? Sugod sa sinugdanan. I-adapt gyapon nato ni nga thinking kaning two-port systems approach. So we'll try to look at our system try to look at our circuit as a system, no? As a system. So instead of an actual circuit, okay, instead of like this, no, kung fixed bias, we could model any circuit configuration using only these circuit elements. Again, di ba, ang atong system will be characterized by these parameters: input impedance, output impedance, and voltage gain. So, asa na sila gamit if we adopt a systems approach? Diba? So, this is our system, characterized by the input impedance, output impedance, and our voltage gain. So, our voltage gain is characterized by the dependent source, AV. AV, but kung ng AV, di ba, kanang unitless. So may i-multiply nato sa AV para may mo siyang voltage. Of course, something that is measured in volts. So VI. Asa man measure si VI? VI is measured here. The voltage sa input na portion. That's VI. So whatever the voltage is here, multiply na to og AV, that's the value of the dependent source na model sa atong system. So this works for any configuration. Dili lang fixed bias. No? So dili ba mala siya malatag mobalik sa circuits 1 nga simple circuit lang atong gina analyze. So this is our amplifier system. Okay. And yung system boundary is kanilang, no? Muna na siya ang boundary sa atong amplifier. The load will be connected here. Outside na siya sa atong amplifier. So di siya part sa amplifier. Of course, dili part sa amplifier ang load. That's load RL. And the voltage across the load is the output voltage, VO. So sa to atong pag-model sa source, internal resistor, RS, and AC voltage source, VS. Na. So, that's it. No? Mao na siya ang systems model for any amplifier configuration. So, we could now solve for the value of AVL and AVS. AVL and AVS. No need to solve for AVNL because naman tayo formula ana sa table sa page 293. So the formulas for each of the gains are these. For AVNL, or at least the expression for the gains, actually AVNL is equal to, of course, VO over VI. This VO and this VI. But this VO is as if wala pa ang load. So, unloaded. Of course, may palang daan. So, for AVL, still the same formula as this one. VO over VI gapon. But na ng load. So, for sourced, or AVS, sourced na voltage gain, or voltage gain with the effective source, it's VO over VS. But most of the time, it will be difficult to solve for VI and VO. And especially nga natay value na for AVNL. So why not? Ang point here is we have a specific value, or specific formula for AVNL, and we have difficulty of solving for VO and VI. So why not? We find a generic formula for AVL and AVS in terms of, or as a function of, AVNL. Ano lang. Because, hitting two birds with one stone, bitaw. Bitaw, natay formula for AVNL. Dayon, maglisod pag ito pangita sa value ni AVI and AVO. So we create a formula for AVL and AVS as a function of AVNL. So it goes like this. AVL is VO over VI. Ano na siya? Voltage divider. AVL. AVNL ni siya. Okay. AVNL ni dire. AVNL times VI. AVL is the loaded voltage gain. Sige, before that one, ma-derive naman siguro. Voltage divider man yun. Focus your attention lang at this portion. Okay? Diba? Wala lang siya voltage divider, right? Pwede siya malag voltage divider gid siya. Focus your attention lang there sa kanang a portion sa system. VO is equal to voltage source, which is AVNL times VI over RL plus ZO. Okay. Wala, di ba? Basta voltage divider. If this is VS, R1, R2, V2 is VS, R2, R1 plus R2. Sakto na? Voltage divider. So our V2 is VO and our VS is AVNL times VI. Diba? Before I proceed, any questions sa pag-derive na ko ani?
None, sir.
Sabtan la, no? Kung naman siya, again, voltage divider na concept. So, VO is equal to AVNL times VI. RL over RL plus ZO. So, kung tayo value for VO and VI, ato lang i-transpose to the other, no, divide both sides by VI. So, VO over VI is equal to AV and L RL over RL plus ZO. And remember, VO over VI is equal to AVL. So, synthesizing everything, we have a formula for AVL. AVL is equal to AV and L RL over RL plus ZO. So the formula for AVL is a function of AV and L. If RL is very much greater than ZO, AVL would be approximately equal to AV and L. If RL increases, AVL also increases. Okay. So now how about for AVS? Dire. Here, again, this time, focus your attention in this part of the system, which is also a voltage divider, right? So, makompute na itong value for what? VI. So, AVS is equal to VO over VS. VI such that AVS is equal to marag the same og itsura sa kaninga formula. AVL times ZI over ZI plus RS. So that's the formula for ABS in terms of or as a function of AVL. Or if we want gyud a formula na in terms of AV and L gihapon, i-combine lang nato, no? Kani AVL man eh. So ato lang ni i-substitute ang whole thing here. So natay formula for AVS, that is a function of AV and L. So AVS is equal to AV and L times RL over RL plus ZO ZI over ZI plus RS. Yeah. So another formula for AVL and AVS as a function of AV and L. This one and this one. Usually, given mo ang mga value ni RL and RS. Okay, so given eh. O kung dito sa silong. Usually given ang value sa load o value sa source. Si AV and L makompute, si ZI makompute, si ZO makompute. So, dali na kainin sila. Yeah. So, if you have question, just interrupt me anytime, okay? Let's try to solve an example now to practice what we have just learned. Take note lang kung screenshot mo or masulat ninyo, sulat na daan. Okay? At least kaning duha. No? This one and that one. Okay, later pa man ako i-upload ang atong notes sa e-learn. Take note lang aning duha ka formula. So let's try to solve an example. Okay, so kani. So given this circuit, a fixed bias configuration, BJT amplifier, with RL equal to 2.7 kilo ohms and a voltage source with internal resistance of 1 kilo ohm. So A, let's solve now for the amplifier parameters. GI, GO, and AB. Of course, AB and L. Check daw. So ZI, ZO, and AVNL. Again, di na natin i-derive. Let's just go to page 293 for the formulas. Di pa dahil kayo na. Wala pa man tayong mga DC parameters, IE and RE. How much is IE? So page 193. No? Ito solve IE. I fixed device mo, di ba? IB. So IB is equal to VCC minus VBE. VCC is 24 minus 0.7 over 560K. So IB is equal to 41.6 microamperes. IE is 81 times 41.6 micro. .37 milliamperes. RE 26 millivolts over 3.37 milliamps. RE is equal to 7.71 ohms. Okay. So ZI. Input impedance from our table is equal to RB parallel beta RE. So RB parallel beta RE. Ilan yung answer? Nasa manging ani?
Yes, sir. Walang
Pwede,
616.12 ako.
pwede lagi dahil ni approximate og beta RE, oh. Diba nasa formula na to nga if RB is greater than 10 times beta RE, pwede na dahil ang ZI is equal to beta RE. Pero sige lang. So, I think pala naman tag-answer 617 or 616 point something. So, dolo na siya. 616, 617. So, ZO is, wala may RO given, no? So, maybe, ang assumption here, basta dili given ang RO might be infinity. So, pwede na mo gamit og katong ZO is approximately equal to RC. 2.2, 4.3K. 4.3 kilo ohms. For AV, again, walay RO. So RC over RE. AV and L. Negative RC over RE. $4.3K divided by 7.71. 557.4. So, ayan na. 557. Do you all agree with these answers?
Ang negative, sir.
Negative
Ah,
yun.
yeah. Kaya gina ko kalimutan. So, negative 557. Thank you. So, yeah, I think correct na siya. So, how about AVL and AVS? So, atong ikuan, systems point of view. Sige nga ni. Na. Okay? So, ito na. AVL is equal to AB and L. Ito siya. RL over RL plus 0. RL over RL plus 0. Nasa mga 215. Okay. And AVS. AVL ZI over ZI plus RS. Nasa mga 82. 82. Okay? Do you agree with my answers?
Yes, sir.
Yes, sir.
All right. Okay, thank you.
Excuse me, sir. Pwede
Yeah.
makita ang circuit?
Kani. Okay, Raman.
Okay na, sir. Thank you, sir.
Sige, sige.